Hello and welcome back to our channel Zenith Academy Online. I am Shahana and today we will be doing Trigonometry class 10. Now I know this topic is a little bit difficult for you, but I assure you if you understand the concept and learn the tricks how to remember these trigonometric identities, you will be able to solve these questions in minutes. So without wasting time, let's start. So now we are very familiar with this three-sided figure, that is the right angled triangle. And the moment we see this right angled triangle, what clicks in our mind is the Pythagoras Theorem, which is hypotenuse is equals to square root of perpendicular square plus base square. Now, why we need Pythagoras Theorem, why we need to find these sides, and why we need to find the angles, and why this finding the angle of this three-sided figure is so important? Let's see. Now we have seen airplanes flying, so the pilot need to fly it at a particular distance, a certain height, and also at a certain angle. Similarly, while landing also, the airplane needs to be at a certain angle. It needs to be landed at a certain angle, at a certain height as well, and at a certain distance. So to calculate these angles and these distance, we require how to calculate that right angle triangle, the sides of that right angle triangle, and that is where the trigonometry came in picture. Similarly, if we take other examples, we have seen the construction of a bridge. So if you see clearly here, while construction of a bridge, certain pillars are created. First they are at a certain height and certain distance, and they need to be inclined at a certain angle. And for this, we require trigonometry. So now, let us understand what is trigonometry. So, what does the definition say? If you clearly look at this word, trigonometry, trigono in Greek is actually the symbol, or it actually means triangle, and metry means the measure. So, in short, it is the measure of a triangle. And what our definition says is, trigonometry is the branch of mathematics that is concerned with the calculating the angles of triangles or the length of their sides. So, trigonometry is basically the calculation of angles or the length of the sides of a triangle. Now, let's see, for suppose this is a right angle triangle ABC. Now, in trigonometry, there are 6 functions. There are 6 trigonometric functions and 3 basic ones. So, first what we need to learn is that 3 basic functions, so that other functions we can learn accordingly. Now, first 3 functions are sine, cosine and tangent. Now, what are sine, cosine and tangents? Let's see, this is our triangle ABC. Now, in this triangle, this is our 90-degree angle, and let's suppose this angle is theta. Now for this theta, AB is the perpendicular. Let's mark this side as P. BC is the base. For suppose this is, let's say, B. And AC is the hypotenuse. So let's mark this as H. Now what trigonometry is all about? Finding ratio for this theta. So we have only 3 sides for this triangle. So what are the possible combination for the ratios? Let's see. First may be perpendicular upon hypotenuse, that is P upon H. For other ratio will be B upon H. And what other ratio can be? Perpendicular upon base, because this is only remaining now. So now what they did in trigonometry, this ratio, the perpendicular upon hypotenuse, they named it as sine theta, or actually this is the short form, it is sine. The word is actually sine. In short we write it as sine theta. For base upon hypotenuse, this ratio for theta is called cosine, or in reference to this theta, it is cos theta. And perpendicular upon base is the tangent or tan theta. Now, see, if we clearly write it here, sine, cos and tan, these three are the basic functions of trigonometry and its ratios we know now. How to learn these ratios? This is perpendicular upon hypotenuse, base upon hypotenuse and perpendicular upon base. So, we have a video on the trick how to learn this trigonometric function. We have that phrase, some people have curly black hair through proper brushing. That trick we have covered in a different video. Please do check it out. And you have any different phrase, please do let us know in the comments below. So, now we have found out these three ratios. If I want, I can write hypotenuse upon perpendicular as well. This will also be another ratio. Hypotenuse upon base is also another ratio. And base upon perpendicular can also be the other ratio. So, what will we name it? So, the reciprocal of sine, that is cosecant theta in reference to this angle. So, it will be cosecant. This is secant, the reciprocal of the cosine function, and the reciprocal of this tan or the tangent function is cotangent, or in short we say it as cot theta. For this we say is sec theta. So now we have sine theta, the opposite of sine is the cosecant theta or cosec theta. Cos theta, which is based upon hypotenuse, and the reciprocal is sec theta or the secant theta. Tangent theta, the reciprocal is cotangent theta or cot theta. Let's read this. So what is this? Sine, cosine and tangent are basic three functions of trigonometry. Sine is equal to perpendicular upon the hypotenuse. Cosine, it is base upon hypotenuse. And tangent is the remaining two sides, that is perpendicular upon base. The reciprocals are, for sine the reciprocal is cosec, for cosine the reciprocal is sec, and for tangent the reciprocal is the cotangent or the cot theta. Let's see relations between different trigonometric ratios. The set one, we have already done it. The reciprocal one, let's see. If sine and if cosec is the reciprocal of sine, so how can we write it? Sine A is equal to 1 by cosec A, or cosec A is equals to 1 by sine A. Similarly, the other two functions will be same. Cos A is equal to 1 by sec A, sec A is equal to 1 by cos A. And similarly, tan equal to 1 upon cot A, or cot A is equals to 1 upon tan A, or the reciprocal. Now, the most important, tan A is equals to sine A upon cos A. Now, how is this possible? If you see clearly, sine A is what? Perpendicular upon hypotenuse. And what is cos A? Cos A is base upon hypotenuse. So, if we write it like this, hypotenuse and hypotenuse will get cancelled, and what we'll get is perpendicular upon base, which is actually tan theta. So that is why tan A, here the angle is supposed to be, angle is marked as A. So if angle is A, then tan A will be equal to sine A upon cos A, which is actually this. Similarly, since cot is the reciprocal of tan, so instead of sine A upon cos A, what we'll get? Cos A upon sine A. Let's move forward. In order to learn this ratio well, let's solve some questions. Prove the following identities. First question. Sec A minus 1 upon sec A plus 1 equal to 1 minus cos A upon 1 plus cos A. See, if I take LHS. So what LHS is? Sec A minus 1 upon sec A plus 1. Sec A minus 1 upon sec A plus 1. Now we know sec is the reciprocal of cos. So we can write it in terms of cos. So convert it. What will be sec A? The reciprocal. So 1 upon cos A minus 1 upon cos A plus 1. So now what we need to do? We need to just solve. Take the LCM and solve. Now see, here it is cos A only. So cos A, it is 1 cos A into 1. So this will be 1 minus cos A. Now this is whole upon, take LCM cos A. 1 plus cos A into 1 is cos A. So now it's easy. Cos A and cos A will get cancelled. So what we'll get? 1 minus cos A upon 1 plus cos A, which is equal to our RHS. This is our RHS and hence proved 1 plus sine A upon 1 minus sine A is equals to cosec A plus 1 upon cosec A minus 1. Either you take LHS or you take RHS to solve. Let's take here the RHS. You can take LHS as well. So now cosec A plus 1 upon cosec A minus 1. This is our RHS. So this is equal to, now cosec A we know is the reciprocal of sine. So we can write it in terms of sine. 1 upon sine A plus 1 upon sine A minus 1. Now what it will be? 1 plus 1 into sine A. So 1 plus sine A upon sine A whole upon, let's take LCM here as well. 1 minus sine A upon sine A it will be. So sine A gets cancelled. What is remaining? 1 plus sine A upon 1 minus sine A. Which is what? Our LHS, and hence proved. Now let's see our second set of relations, square relations. Now what are the square relations between the trigonometric functions? First is sine square A plus cos square A is equals to 1. This is sine square A plus cos square A is equals to 1. So this means if I write 1 minus cos square A, it will be equal to sine square A. Just shifting cos on other side, cos on other side, or similarly if I shift sine on other side, it will be 1 minus sine square A equal to cos square A. So this is the most important and basic square relation. Sine square A plus cos square A is equals to 1. The second relation is 1 plus tan square A is equals to sec square A. So if I write sec square A minus tan square A, shifting tan on the other side, what I'll get? 1. So sine square A plus cos square A was equal to 1. Now this is a relation between sec and tan theta, or sec A and tan A. So this is sec square A minus tan square A is equals to 1. And the last is 1 plus cot square A is equals to cosec square A. 1 plus cot square A. See, sine and cos we know. Now we have a relation between sine and cos. Sine square plus cos square A is equals to 1. What are the remaining ratios? Tan, cosec, sec and cot. So how are they related? tan and sec are related, and cot and cosec are related. So 1 plus tan square A is equals to sec square A, and 1 plus cot square A, remember this is square, is equals to cosec square A. So these are three identities. Sine square A plus cos square A is equals to 1, 1 plus tan square A is equals to sec square A, and 1 plus cot square A is equals to cosec square A. This we need to remember. Let's solve some questions so that we can memorize these identities. Now, first question, sine A plus cos A upon sine A minus cos A plus the reverse, sine A minus cos A upon sine A plus cos A should be equal to 2 upon 2 sine square A minus 1. Now, see, before solving the question, what we first should look at it is, this is our LHS, and what we need to prove, let's suppose this is RHS. So what we need to prove is also in terms of sine only. Here the question is in terms of sine and cos, and our answer needs to be in terms of only sine. So what we'll do, we'll convert cos into sine, and now we know the relation as well. Sine square A plus cos square A is equals to 1. Let's see how we can use that. See, for LHS, sine, this is here, these are in their basic, they are the basic terms. Now what we can do is just add it. So when we add these, what we do, we first take the LCM. How? By multiplying both the denominators. So this will be sine A minus cos A into sine A plus cos A. When I am writing this, you should immediately, you should have clicked that what this property is, A minus B into A plus B. So we write the numerator first. Sine A plus cos A should be multiplied by this sine A plus cos A. So this will be sine A plus cos A whole square, and similarly this and this should be multiplied, that is sine A minus cos A into sine A minus cos A. So sine A minus cos A whole square. Now this we know, this is A minus B and this is A plus B. So A square minus B square, it is a property, and this is A plus B whole square and this is A minus B whole square. So we just need to open the brackets, and here we need to write the property. It will be, for the denominator we know it was A square minus B square, so let us write sine square A minus cos square A. And for the numerator, when we open the brackets, what it will be, sine square A plus cos square A. Since it is plus, so it will be 2 sine A cos A. And so our other term was sine A minus cos A whole square. So what is our property? A minus B whole, for A minus B whole square, A square plus A square minus 2AB plus B square. So in the same terms we will write sine and cos, sine square A minus 2 sine A cos A plus cos square A. So now what we can do, plus 2 sine A cos A and minus 2 sine A cos A will get cancelled. So what we'll get, sine square A, and here it is cos square and cos square A. So 2 times 2 sine square A plus cos square A, taking 2 common, upon sine square A minus cos square A. Now what is sine square A plus cos square A? We read it was equal to 1. So this is 2 into 1 upon sine square A minus cos square A. Now here, since RHS is in terms of only sine, we need to convert this cos, and we know that cos square A is equals to 1 minus sine square A. Let us write it in this form. Let us write it sine square A minus 1 minus sine square A. By the same property, sine square A plus cos square is equals to 1. So 2 upon, now see, since this is a minus sign, so when we will open the brackets, it will change. So here, since this is plus 1, so plus minus is minus, so this is minus 1, and this is minus sine square, so minus minus will become plus, so plus sine square A. Now we have almost got our answer. It is 2 times sine square A minus 1. So let's write 2 upon 2 sine square A minus 1, and hence this is what we need to prove. Let's see other question. 1 plus cos A upon 1 minus cos A is equals to tan square A upon sec A minus 1 whole square. See, this is our RHS, and either we can take LHS or we can take RHS, but since here it is only given cos and we need tan and sec in the RHS, what will be easier for us to convert into cos is this RHS. So to perform operations, we will first take RHS, tan square A upon sec A minus 1 whole square. Let's take this in form of sin and A. Sin square A upon cos square A upon, what is sec A? It is the reciprocal of cos. So 1 upon cos A minus 1 whole square. Now we can take here the LCM and solve this. So what it will be? Sin square A upon cos square A upon 1 minus cos A whole square upon, I can write cos square A here. See, 1 minus cos A upon cos A whole square it was. So I can write 1 minus cos A whole square upon cos square A. So this and this will get cancelled. What is remaining? Sin square A upon 1 minus cos A whole square. So now this is sin square A, and we know the property sin square A plus cos square A is equals to 1. So how can we write sin in terms of cos? 1 minus cos square A. This is 1 minus cos square A upon 1 minus cos A whole square. So now see, this is 1 minus cos square A. This is what? A square minus B square. 1 square is 1 only, we know. So this is A square minus B square. So now if we just write the property 1 minus cos A into 1 plus cos A upon 1 minus cos A whole square. Now it is very easy. See, this is 1 minus cos A whole square. So if we cut this, what will be remaining here? 1 minus cos A only. So now we have got the answer. 1 plus cos A upon 1 minus cos A. This is what our LHS is. Let's see other question. Now, our question is tan square A minus tan square B is equals to sine square A minus sine square B upon cos square A into cos square B. Now, if we see clearly, this tan square A and tan square B, we can write this in terms of sine and cos. So, to solve, we can take LHS. This is how we decide how to solve, what we need to solve first, LHS or RHS. So, it is easier for us to write tan in terms of sine and cos. So, let's take LHS. Tan square A minus tan square B. So, if we write this in terms of sine and cos, sine square A upon cos square A minus sine square B upon cos square B. Simple. Now what we can do further, we don't have any option, we can use this mathematical operation and solve. Cos square A into cos square B. See, in RHS this is only the denominator, but in the numerator we require sine. Let's see how can we get it. Now when we have taken the LCM by multiplying two denominators, let's cross multiply and get the numerator sine square A into cos square B minus sine square B into cos square A. So, now since in the numerator we only need the terms of sine, so we need to eliminate this cos term from here. How can we do that? See, we know sine square A plus cos square A is equals to 1. So for cos square B, we can write it as 1 minus sine square B, and for cos square A, we can write it as 1 minus sine square A. Now here, this is sine square A into, if we write cos square B, what it will be? 1 minus sine square B. Let's write it here. Sine square A into 1 minus sine square B. This is our minus sign. So here minus sign. Sine square B into cos square A. So how will we write this? 1 minus sine square A. So sine square B into 1 minus sine square A. This is whole upon cos square A into cos square B. Now sine square A, now what we can do, just open the bracket, multiply and solve. So sine square A into 1 is sine square A minus sine square B into sine square A. This is sine square A into minus sine square B. So this is the term. Now please be careful, this is minus sine. So minus sine square B into plus 1. The minus plus will give us minus. So this will be minus sine square B. And now minus sine square B into minus sine square A. So minus minus will become plus. So sine square B into sine square A. This is whole upon cos square A into cos square B. Now it is almost over. See, minus sine square B and into sine square A will get cancelled. Plus sine square B, sine square A into sine square B. So now we have got our answer. Sine square A minus sine square B upon cos square A into cos square B. And this is what our RHS is, hence proved. The other question, cos A upon 1 minus tan A plus sin A upon 1 minus cot A is equals to sin A plus cos A. Now, see, if we take LHS here, in RHS we just need sin and cos. So, if we are taking LHS, we need to convert these into sin and cos. Let's see. Cos A upon 1 minus. Now what is tan A? Sin A upon cos A. So this will be 1 minus sin A upon cos A plus sin A upon what is cot A? 1 minus the reciprocal of tan, that is cos A upon sin A. So now what we need to do? We just need to solve. Cos A upon, let's take the LCM and cos A minus sin A upon cos A plus sin A upon, same here, take the LCM and multiply, sin A minus cos A upon sin A. Now cos A and sin A, they'll go in the numerator. If we multiply, they will become reciprocal and they will go in the numerator. So what will the term become? If cos A comes to the numerator, this will be cos square A upon cos A minus sin A. See, how have I done this? This is actually cos A upon cos A minus sin A. This will become cos A upon 1 here, and we'll multiply cos square A upon cos A minus sin A. This will give us. So this is plus. Now in the same way, sin A will go to the numerator, will be multiplied by the numerator. So sin square A upon sin A minus cos A. So now what we have, cos square A upon cos A minus sin A plus sin square A upon, now see, here it is cos A minus sin A. So if I write here, let's say I take minus common here and I can write this as cos A minus sin A. I can write this, I can take minus common here and cos A minus sin A. So when the bracket will open, it will be sin, this is minus minus plus, so it will become plus sin A and minus cos A. So for cos square A, if I will write cos square A upon cos A minus sin A, and since this minus is here, so here it is minus plus is minus, so whole it will become minus, and here it will be minus sin square A upon cos A minus sin A. Now cos A sin A, cos A sin A, we have a common denominator, so LCM is easy. It will be cos A minus sin A. What is in the numerator? Cos square A minus sin square A. Now what? Algebraic identity a square minus b square we have used before also. In the same way, cos a minus sin a into cos a plus sin a upon cos a minus sin a. So, we can cancel these two terms. What is remaining? Cos a plus sin a, which is what our RHS is. Hence, proved. Now, let's see some more questions. Now, in this question, please be careful with the algebraic identities and the common we will take. Please see it carefully. See, what is the question? Cos cube a plus sin cube a upon cos a plus sin a plus cos cube a minus sin cube a upon cos a minus sin a. Since we are taking this LHS whole, we need to prove that this whole term is equal to 2. Now, if we clearly see this numerator, cos cube a plus sin cube a, what is this in the form? A cube plus b cube. We have an identity a cube plus b cube, which is equal to a plus b whole into a square minus ab plus b square. Cos cube a plus sin cube a. So what we can write? Cos a plus sin a into cos square a minus cos a sin a plus sin square a. This is whole upon what it is? Cos a plus sin a. So this is the first part of our LHS. Now see, cos a plus sin a and this is cos a plus sin a. We can cut this. Now this whole term is added to this term. Now see here what this is. A cube minus b cube. Here we have used a cube plus b cube property, and now what is a cube minus b cube? A cube minus b cube is equal to a minus b into a square plus ab plus b square. So now here we'll write this in the same way. Cos a minus sin a into what is our next term? Cos a square. So this will be cos square a plus cos a sin a plus sin square a. This whole is divided by cos a minus sin a. Now in the same way, cos a minus sin a will cut, and cos a minus sin a will get cut. So now in both these terms we see cos square a plus sin square a. Here also cos square a plus sin square a, and we know sin square a plus cos square a is equals to 1. 1. See, cos square a plus sin square a is 1. So 1 minus cos a sin a. So 1 minus cos a sin a. We have a plus sign. We have an addition sign here. So this is plus. Now here also cos square a plus sin square is 1 plus cos a sin a So now it is easy. Cos A and sin A will get cut, minus n plus sine. So now this is 1 plus 1. This is equal to 2, which is what RHS is. Tan A plus 1 upon cos A whole square plus tan A minus 1 upon cos A whole square is equals to 2 1 plus sine square A upon 1 minus sine square A. Now see, if we take this whole LHS, this is in terms of tan and cos, and what we need the answer is in terms of sine. So we need to convert all these terms into sine. Now see, for tan we know we can write this as sine A upon cos A plus 1 upon cos A whole square plus tan A minus 1 upon cos A whole square. So sine A upon cos A minus 1 upon cos A whole square. Now we have A plus B whole square and A minus B whole square. Just solve it, open the brackets. See, denominator is common. So this is sine A plus 1 upon cos A whole square and sine A minus 1 upon cos A whole square. So sine A plus 1 whole square upon cos square A plus sine A minus 1 whole square upon cos square A. So here the denominator is common. Cos square A sine A plus 1 whole square. So we'll open the brackets. This is A plus B whole square. So sine square A plus 2 sine A plus 1, and it is here, it is what? Plus sine square A minus 2 sine A plus 1 So now here, see, 2 sine A and minus 2 sine A gets cancelled. What we have, let's take 2 common because it is 2 sine square A plus sine square A. So it is 2 times sine square A and 1 plus 1 is equals to 2. So let's take 2 common. What we will get? Sine square A plus 1 upon, now this is cos square A. Now what we can write for cos square A? Sine square A plus cos square A is equals to 1. So yeah, we can write this as 1 minus sine square A. So 2 1 plus sine square A upon cos square A can be written as 1 minus sine square A, and this is what our RHS is. Easy? Let's move on. Next question. Now what our question is, x cos A and y sin A. See, is this whole term, this whole equation, the coefficient of cos is x and sine is y. So x cos A plus y sin A is equals to n. This is our first term. And the second equation, what it is? Here the coefficient of sine is x. Here it was the coefficient of cos. X was the coefficient of cos, and now here it is for sine. X sin A minus y cos A is equal to n. These two equations are given to us. Let's mark this as second equation. So what we need to prove, x square plus y square is equals to m square plus n square. See, let's first write these equation. X cos A plus y sin A is equal to m. X sin A minus y cos A is equal to m. Now what we need to do is x square plus y square. So how is equal to m square plus n square? Now if we take m square plus n square, so what will this be equal to? M square plus n square. M square plus n square. So this implies m square. What will be m square? This whole term equal to whole square. And what will be n square? This whole term equal to whole square. Right? So for m square plus n square, how can we write this? This whole term, that is x cos A plus y sin A whole square. Now, if we write this term, x cos A plus y sin A whole square, and this is n square plus n square, so plus x sin A minus y cos A whole square. Now see, these calculations are long, but they are not very complicated. They are actually easy. We just need to be careful about the signs and about the properties, algebraic properties we need to use, and then it will be easy. See now, this is a plus b whole square, so we can open the bracket. X square cos square A, this will be, plus 2ab will be 2x cos A y sin A. So 2x cos A y sin A plus, what is this? Y square sin square A. Now plus this whole term, this is a minus b whole square property. So let's write this, plus x square sin square A, x square sin square A minus, since this is a minus a minus b whole square, 2 sin A y cos A plus y square A cos square A. Now please see this carefully, this is very easy. See, x y cos A sin A cos A, in multiplication the terms can be shuffled and this is the same term actually. So plus 2x cos A sin A cos A y sin A can be cancelled by 2x sin A y cos A. So this is cancelled. Now if we see this, x square if we take common, what will remain? Sin square A plus cos square A. And here if we take y square common, what will remain? Sin square A plus cos square A, which is actually what? Equal to 1. X square into cos square A plus sin square A and here we take y square common, sin square A cos square A common, when we take y square common, so we will get sin square A plus cos square A. So what is this? Cos square A plus sin square is 1. This is 1. So what? X square plus y square is what we will get. And this is equal to m square plus n square is equals to x square plus y square. Hence proved. Okay. So this was all for today's session. I hope I was able to clear all your doubts. I have covered this chapter in 3 videos. Please watch the remaining 2 videos as well so that you can be thorough with this topic and you can score full marks in this topic. Thank you. Thank you for watching, and if you haven't yet subscribed, please do subscribe. Keep the learning on.